How do you write a series in sigma notation? Let's find out. To write this series in sigma notation, the first thing is, remember, sigma is this letter here. And what we want to do is we want to take this expanded form and figure out where it starts. So where does it start and stop? There are 6 values here. So basically we're going to say we'll start at 1 and stop at 6. So now we need to figure out this part. But how do we do that? The first thing that we want to do here is to get the pattern of the sequence. And as we go from 1 through 11, notice that it increases by 2 each time. And if we wrote out the terms 1, 3, 5, 7, 9, and 11, these all change by 2. In other words, this is an arithmetic sequence where we're adding 2 each time. So we're going to say the common difference of this arithmetic sequence, because we're continually adding the same amount each time, the common difference is 2. We're adding 2, adding 2, adding 2, adding 2, adding 2. So we add 2 each time. That's our common difference. So next we're going to say that the first term in this sequence will be 1. So what we need to do is to rewrite everything. A sub 1 is what we're going to use to represent the first term, and we normally use the letter D to represent our common difference. And the formula that expresses this is, the general form is A sub n equals A sub 1 plus D times n minus 1. This is how we write any arithmetic sequence. We know D is 2, so we can go ahead and plug in 2. We know A sub 1 is 1, so we're going to go ahead and plug in 1 right there. And so what we have is an expression that describes how we get each term. And we're going to take that and write it here to represent our series. So we're going to rewrite everything and say that we have sigma, the starting index is at 1, the ending index is at 6 because we had 6 things that we had, and we're going to put this expression here, 1 plus 2 times n minus 1, and all of this right here is what our sigma notation is for that series. So we need to rewrite this series in sigma notation. Remember, sigma is that E looking letter. So this is what sigma looks like. Our Greek letter sigma here. On this term, let's look at the pattern here. So we know we're starting at 1. We're always going to count starting at 1, 2, 3, 4, 5, 6. So it's going to stop at 6. And we just need to figure out what goes here. What are we going to use to get each of the terms? So we need to get the pattern of these numbers. So 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, and so on. As we go, we're multiplying by 2. So this one is not addition, this one is multiplication. So it's an example of a geometric sequence which will have a common ratio. So the common ratio here was 2 because 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, and so on. So we're going to say that the common ratio is 2. And we also need to describe the first term. The first term here is 5. So the first value that we have for our first term here is going to be 5. And let's associate names with these. So first term or first value we're going to say is A1, A sub 1. And the common ratio, we're going to use the letter R because ratio, R, okay? So R. All right, so now we're going to go ahead and express this geometric sequence here. And we have A sub n equals A sub 1 times R to the n minus 1. That's how we write any geometric sequence. So the A sub 1 we know is 5. And R we know is 2. So all we need to do right now is just to write this to finalize our series here. So this is our series, and we're going to express this again in sigma notation. We're going to say sigma, that's that E looking letter again. We're going to start it off at n equals 1 and stop at 6. So n equals 1, because again there's 6 terms, to 6. And then we're just going to fill in what we have. So 5 times 2 to the n minus 1.